Hey, hello there, and we are back. It's 1 in the morning, but I guess we can continue now the 18 puzzle of Advent of Code. So yeah, we are just going to continue where we left off, which is part 2. We got to the solution of part 1. It was a pretty easy puzzle where we computed the exposed surface of a lava droplet or boulder, but it was a very naive computation of the exposed area, because it seems like inside this this boulder there are pockets of air, and yeah, on the previous, I guess I'm going to cut the previous take on a separate video. So in the previous video I was a bit confused by this explanation here, but I think I understand it now. Yeah, it says that instead of computing the area of this boulder as we did before, consider only the cube sides that could be reached by water and steam as the lava droplets tumbles into the pond. So basically the droplets are falling there, and it basically the water will fluid fill into the droplet and touch everything that it could touch, except, you know, if there are pockets of air inside of the droplet, then the water won't reach it. And this should be like a simple fluid filling algorithm, I think. So yeah, let's try to implement that. Oh, by the way, I should also check the example that it says here. On this example, exactly 1 cube of air is trapped within the lava droplet at 225. So the exterior surface area of the lava droplet is 58 instead of 64, so 6 less. Yeah, because the 6 sides of that cube are like inside of the droplet, and the water is not exposed to that. Makes sense. So I guess that means that all the neighbors of this should be on this list. So that would be 3 to 5 and 1 to 5. Let's look for them real quick. 3 to 5, yes, and 1 to 5, yeah. Then it will also be 2, 1, 5 and 2, 3, 5. Yes, 2, 1, 5 and 2, 3, 5, and 2, 2, 4 and 2, 2, 6. So again, yeah, here there are, and this seems to be sorted in some way. Like they were all together in the list, and like adjacent. Okay, I wonder if all the pockets of air are of size 1. I really doubt that the solution will be that for the actual puzzle, which has way more points. But if that is the case, maybe we can get away with not doing any fluid filling algorithm. So here, what we are doing for the part 1, let's copy this code. Let's call this naive, not total area, but naive exposed area. And yeah, I just remembered that when you rename something, these things are not renamed on these formatting macros, which is a pity. But let's copy this code, shamelessly repeat ourselves. Then we can think of drying it up. But let's say non-naive exposed area. Exposed area. Okay, let's see if we can get by with no not doing fluid fill. So here we have each of the neighbor points, and we say, okay, if the droplet point, what are we doing here? We are checking to see if if this neighbor like is in the droplet, if it's part of the droplet. So I guess we can. Oops, let's do this. And we could say, well, if this, then return true. Let's short circuit this, and otherwise, I guess the return here is not needed, I think. Otherwise, what are we going to do? We can say, we can check for pockets of error of size 1. So I doubt that this will be the solution, but we can check it real quick. So if this neighbor is surrounded by droplet points, then it is a pocket of error, and it should be considered inside the droplet also, and subtract from this calculation. All right. So let's copy this code. Also, like shamelessly, yeah. Let's copy this. This array, and we're gonna have. Well, I guess we have to extract this XYZ. We can say let XYZ. We are going to shadow the previous variables and neighbor. And we can say let is air pocket be this thing, iterates it. I guess if we are here, well, yeah, we can iterate it and check if every, I think. I don't know if I am missing something here. What are you complaining about, Rust? Yeah, expected bool, okay, yeah. Return, like if it's pocket of error, yeah, return, well, just return is pocket of error, is error pocket. Are you happy with that? Yes, okay. This XYZ, yeah, let's mismatch types. What are these? Now dereference. Yeah, dereference is what I want, right? What is neighbor? Oh, it's a double reference. Okay. I guess it's a double reference because iterators already filter takes references. So I guess here we can do into iter. And yeah. Neighbor now should be a single reference. Great. And here, these things should be what? Why are you complaining? Doesn't it make sense? No, I guess I have to dereference. Yeah, okay. I'm very rusty. All right, so we have the iterator and we can ask if every or all. Yes. If all of them I don't know how to call it, so let's call it point P. If all of them are part of droplet points, I guess. And P, yes. Does this make sense? I guess here we can also do into iter. I don't know why this thing is not complaining. No, now it does complain. Because it's expected. Yeah. Okay, let's keep it as an iterator. But here the contains, I guess the contains can take a reference or a double reference, or is there some dereferencing going on there? I don't know. Anyway, yeah, let's see what this prints actually. Oh, let's do it with the sample first. Okay, for the sample, it does print 58. That's great. And we actually have the answer for our given inputs, which I expect to be not the correct one, but let's try it. That's not the right answer. Okay. Your answer is too high. Thanks for the hint. Make sure you're using the full input data. There are also some general tips and blah blah. Okay, and I have to wait 1 minute. Sure. Okay, so this was not the correct answer as expected, I think. So yeah, what's probably happening is that there are pockets of error of size more than 1, and so this thing is not catching those. So that's fine. That's sort of what we expected. So now I have to actually think. All right. One thing we could do is to what? So I already said that I'm thinking of fluid filling and like doing a fluid filling algorithm. I don't know which direction it makes more sense to fluid fill. So one thing we could do is first of all, we are going to need to bound, like, I guess, create a grid or something, like a 3D grid for the points. And does that make sense? Because maybe we can, yeah, now to fluid fill something, we're going to need to expand the space of this. I think I am talking nonsense, like I'm thinking something and saying something that doesn't make sense. So what I'm basically thinking is, should we fluid fill the pockets of air to discover the size and maybe consider them as part of the droplet itself, or should we fluid fill the outside of the droplet to then know what points are on the outside, and therefore we like when we are counting to see what is inside, like basically what are the neighbors, exclude the outside points and yeah, and consider it inside the droplet if it is part of the droplet, or if it's not on the outside, so it will be a pocket of air, something like that. And I think in either case we are going to need either some sort like a grid or some bounding box, like a bounding size, to restrict the fluid filling. Because if we try to fluid fill a point on the outside of the boulder, we're going to, you know, be unbound, like we are visiting every neighbor, and for every neighbor going to every neighbor, especially if we are doing this thing that we're doing here, where we are representing points with unsigned integers, and we basically don't have a bounding for anything. We're going to go to infinity. So we have already seen that the coordinates here are pretty bounded. Like nothing is actually there are no zeros, I think. We can search for 0. Yeah, there are some 10s. Actually, there are no 20s. So everything is below 20, actually, I think. So that's great. Yeah, that makes me think that I want to use a grid, actually. It will make things simpler, I think. Okay, so let's have a constant. Let's have a run up there and say const size, or this is a scan, so scan size. It's going to be size, let's say 20. So what we are going to have is we can have it. Yeah, another thing, that instead of hard coding this, we could also, when we are parsing, we could also take note of the biggest coordinates, or like maximum x, max y, and max z, and just create dynamic like 3D like vector of vectors of vectors, like a dynamic vector of those sizes. But I think we can get away with hard coding here. So the grid will be a static array of size scan size. What's this? Yeah, scan size. I have almost forgotten how to type. It's been so long. Yeah, this is beautiful, right? And what do we want to put here? Actually, what do we want to put? I guess we can put a boolean. No, this is not. Yes, we can say false. So let's say like false means air, and true would mean. Now, can we get away with booleans? Maybe we need 3 states, like to represent air, lava, and trapped air inside of the lava, or maybe trapped air, lava, and like exposed air, or something like that. Because first we are going to do the naive thing, then we can do the fluid fill. Yeah. So let's use an enum for that. We have our type points. We also can have enum of cube type. What was the syntax for enums? It was something like this. Our types will be, I think this is a short thing, so lava, air and trapped air. Does this make sense? I think air pocket, or well, air and exposed or trapped air. Let's say trapped air. And I don't know if trapped. What are you complaining about? Camel case. Oh, okay. Really? Ah, okay, so this is lava. I forgot about everything, even naming conventions. Damn. All right, so we have cube types. So this is going to be, let's do the trick of using use cube type. Let's use these names, and let's start with everything being air, I guess. Air. And you don't like this because cube type is not copy, of course. You have to be deriving. How was the syntax of this thing? Derive copy. Yes, if I can spell. And you cannot derive copy because white. Clone, yes, sure, also derive that. All right, great. So we start with everything being air. We can put the droplet points in there. Yes. Does this make sense? Probably does. Actually, I think, does this still run? It does. 3374. I don't know why I should have added these changes. So we have a part 1 solution at least working. We have this grid. Okay. Now, one thing that we can start doing is for each x, y, z in droplets, droplet points iterator, we can put it on the grid. Yes. So grid. What are we going to do? It's the same, going either direction, I guess. Like we could go z, y, x, but I don't know if we are going to be iterating the grid with 3 nested for loops. So if we are not going to do that, I think it doesn't make any difference. Maybe, I don't know. So we're going to do that, make it lava. And of course this complains because x is this, we can take reference to this. Oh, it's I32. Yeah. If you're going to put these things on the grid, maybe this shouldn't be I32s, maybe these things should be usize. Right, and here I guess you also need to be this. Yeah, and actually we can do something else here. Here we are parsing. Yes, let number be this. And if number is less, or it's less than 1, or number is greater or equal to scan size, then we should panic. Or how was the panic? What was I using for this kind of thing? Was I using panic? Yes, sure. So let's panic and say coordinates out of bounds. Sure, and here just have number. Great. Does this still run? No, coordinate 0 out of bounds. Oh, because do we have zeros actually? Are there zeros here? Then I have my face over there. Search for a 0. What do we want? Search for comma 0. Oh, there are zeros actually. Okay, so we have zeros. That is fine, I think. One thing we could do is just say number plus 1 maybe, and we get rid of the zeros because we don't care about like the actual coordinates. Yeah, right. We could do that. How do we get rid of zeros? Like, how much do zeros bother me? They might bother me, because if the droplet starts at the 0, like is to one side, and there is like a pocket between, that's like, let's say the droplet is to the left of the scan line, or the grid scan, then if there is a pocket like on the left wall of the droplet, and yeah, but it's actually not a pocket, it's exposed to the left, the fluid filling won't reach it if it's like bounded there to the left. So what should we do? We can get away, I think, with doing this +1. Here we probably have to say what are we expecting. Maybe use size here. Does this make it happy? Not really. Maybe this makes it happy. No, we have to explicitly use the turbofish operator. Yeah, great. And we don't have to do this check. Coordinates too big. Okay. Run again, and now we have a 20. So this is, yes, there are some 19s in here. So okay, we have checked that the maximum size is 20. Actually, they go from 0 to 19. Yeah. I'm not really liking this solution so far, but let's keep going with this. And we have the same problem on the maximum size as with the 0. This, even if it fits on the array, I think we have to make it one less. So this should be 22. Kind of ugly. And this here, if the number is bigger or equal to scan size -1, I think it is what we want to ask. Yes. Okay. Kind of ugly. We can keep going. I'm going to switch to the sample input there. Okay. Yeah, I'm not too happy about this, but we can revisit later. Let's annotate this with a hack. This is add 1 to have 0 coordinates, like to have the boulder not sticking to one of the grid faces. The absolute coordinates are not important if everything is displaced the same way. All right. Great. So with that, we have things on the grid. And actually here, we could, instead of asking whether the droplet points contain this, we can probably ask the grid. Grid, okay, and we have the neighbor. I want to ask the grid, I think, because we are going to copy that code and do it for the other calculation. So let's check that the grid is working. Here we're going to take what's neighbor X, neighbor Y, and neighbor Z. And if the grid at nx and ny and nz is a what? Is level, then this is the naive calculation. And nx, what are you complaining? Because this is a double reference. Yes, we can do intuitor, I think. And you're complaining here because there is no partial EQ. Sure. Yes. You could use also the matches macro or something. Nah. Anyway, this should give the same answer as before. 64. Perfect. I guess here we are. I want to do a bit of refactoring, even though it doesn't make sense to. But let's call this thing neighbors. I'm missing an H somewhere. Neighbors. How's this thing spelled? Spelling. Oh, without the U. Okay, maybe that's British English or something. So we have the neighbors and connected cubes. We could actually say if we filter the things that are not lava, we can just return that. And that's it. And we don't do the subtraction, I think. Isn't this the same? Yes, it's the same. Okay. Okay, so now we have a solution to part 1, but with a grid. No, let's not add it yet. Oops. So now we have to do the flood filling to say, actually, we're probably going to flood fill from starting from 0, 0, 0 and mark those things as exposed. Yeah, exposed air or exposed, let's call it. So let's say fluid fill exposed points or cubes. I'm using points and cubes kind of interchangeably here. And let's pass the grid. And I guess I'm going to pass the grid as a mutual reference. Generate this. Beautiful, beautiful signature. This is going to return nothing. And grid is going to be, what is it going to be? A mutable reference to this. Yes, this is kind of ugly to have it that way, so yeah, passing this grid is a bit ugly. Let's do a type definition for this. So type grid is going to be this. Do we need this? Yeah, I mean, yeah, if we want to extract this into a function. So grid is this of cube type. Yeah, sure. And this grid is going to be of type grid. Beautiful. And can you actually infer this if you know the sizes? Left hand side. Sure. Well, let's keep it like this. Actually, if we keep it like this, you don't need to specify the type. Here, where were we? Here, we're gonna get a mutable grid, which is much better than that ugly thing. And to do, of course. What are we going to do for fluid filling? Well, we can say something like let mutable and visited. It's gonna be a vector starting from 0, 0, 0, and while there are unvisited, so while it's not empty, we are going to do things to this. So starting from 0, 0, we are going to say, okay, let x, y, z be unvisited. Actually, this returns, yeah, we can actually do something clever here. While well, there are some unvisited, some points unvisited, we are going to do this. Beautiful. And so when there is nothing else to pop, then we are done. So what are we going to do? Okay, so first we can mark the grid, this thing on the grid as exposed, and actually we probably want to do some short circuiting before, but yeah, we popped, and then we are going to do something similar to this. So let's copy this ugliness into here. What are we going to do with these points? These are the neighbors, basically. So we could actually have a function that returns the neighbors of some. Yeah, we can probably do that, but let's say unvisited push this. We are going to push each of the neighbors. Beautiful. And of course this is unbounded, so or this won't stop. So if we have already visited something, we can stop there, right? That makes sense. And visited in this case means exposed. So if this is already exposed, then continue. And I guess we can say if it's exposed or lava. because if it's lava, yeah, we don't want to fluid fill into lava. So I guess we can say if no, not let matches, if this thing matches exposed or lava, then we'll continue. We won't mark it as exposed. I'm thinking of what happens. Like, does this fluid fill? Yeah, it's gonna add all neighbors. Yes, sure. Oh, we can have also. Yeah, we are starting from 0, so this will underflow here. So that's not good. And if we are going to check bounds here, that's not good either. Like, we have to check before, I think. Oh, I guess in the example they were quite sneaky. Here in this example there are no zeros, so we were not worrying about underflows there. But in reality there are zeros. And I wonder why the real solution didn't explode because of those zeros, right? Yeah, that doesn't make any sense. Like, if we have that, we have already checked that, yeah, there are indeed zeros. Oh, I think it was because we were still using sized integers there. I'm questioning whether we should use size integers and, you know, a hash set instead of a grid like this, and just not care about underflows, overflows, and things like that, and have more hashing. But yeah, what do we want? We can have each of the neighbors, and then iterate over them, filter the ones that are inbounds, and then only push those for fluid filling. I guess that sort of makes sense. So let's copy again neighbors thingy. We can extract this into a function, of course. But let's first do this, and let's say for nx, ny, and nz in neighbors, do what? If the neighbor, we're going to be checking bounds for each of these coordinates. Beautiful. So if yeah, and we cannot even do the calculation beforehand. I guess we could wrap, but that's ugly. Yeah, we're going to be doing conversions and yeah, ugly things. Ugly things are ugly. Neighbors here is of type usize, yes. So this thing will underflow. Beautiful. Let's do, instead of -1, let's do a wrapping sub of 1. Look at that beauty. And if we did the wrapping sub, let's do if then nx less than scan size. So this would catch out of bounds for addition and also for subtraction. So if this and ny less than scan size and nz less than scan size, they are inbounds, and in that case unvisited push nx, ny, and nz. What a beautiful piece of code. Okay, but I think if I didn't make stupid mistakes, this should be something like a float fill thing, right? Right? I don't know. So we're float filling exposed points, beautiful, and marking them as what? As exposed, yeah. So now we are going to do something very similar to before, exposed area. But instead of asking if it's not lava, what are we asking here? If it's exposed, basically, right? So if it is not lava and if it's not lava or pockets of air, so something like this. Does this make sense? Well, let's run it and see. Whoa, we have a much smaller number, but I want to try out with a sample. So this should be 58. Yes, and it is 58. So there were very big pockets. 2010. Damn, is this the correct solution? Yes, and it is. Wow, I'm surprised of the difference here. So this means that the boulder is really full of air. Very interesting. Very, very interesting. So we have a WordPress solution actually. Nice. Let's add these changes then. So I'm happy about that. We can, of course, improve this horrible code. Darn, it is ugly. What do we want to do? What do we want to do? So here we're basically counting what things are. So one thing that I would like to do is probably extract something like a common function to do this counting of faces, like of the cube faces that are exposed. And the float filling is quite ugly because of this wrapping thing. Can we have something like I think if we use a HashMap or something like that. So right now we don't need this to be a hash set as we were doing before. This could be a vector now, like for sure, because we are not hashing into it anymore. So let's change it maybe back. Like we can do that, and well, we could do that and go to the correct input. If we run now, we still get the same answer. So yeah, we don't need a hash set here. Sure, that is a worthy addition. What else? I'm thinking instead of using a grid like this, like as a nested array, triple array, just use a hash map from points to these things, these enums of cube type. It will work the same, but we can go back to points being just signed integers and not care about any underflows or overflows or things like that. We will still need to do bounds checking though. Yeah, but I think it might be better. And if we do that, we also don't need this hack. Yeah, so let's we're running this in debug mode. It takes 7 milliseconds. Let's run it in release mode. It should take nothing. Release. Yeah, when it prints nothing, it means that it's taking less than 1 millisecond. So yeah, it's insignificant. I want to try out to see if the grid could be just a hash map of point to what is this cube type, and we can start with an empty one. Oh, I put the use there. That's interesting. I don't know why if it makes sense to have this down here. Anyway, we cannot do that, and we can just say, well, actually we can get the point here and say, hey, grid points. Let's put a lava in there. Very good. And then here what we are doing is checking if the basically this is asking if it's different than lava, but we have to do a get grid get gives us an option yeah, here again we can do this would be neighbor, and get neighbor if this thing we have to say it's not lava. So this means it's empty. Yeah. So has contains key neighbor. So if it doesn't contain this, okay, and then yeah, this is a mutable thingy. This is complaining, of course, because grid is this thing, but we can say that it is this thing instead. And what are we going to do here? So here we're saying if it's exposed or lava, but actually it can also be nothing. Actually, the pockets of air inside will be nothing. So, yeah. Exposed. Yeah, counting the exposed things there. Okay, I'm getting a bit confused. So let's continue with this change of the 3D grid to this HashMap implementation. So instead of doing this, here we can say some point, let xyz be that point. Sure. Grid, if grid get point, this is complaining because point is this. We can take a reference to this. Great. And we can say if it is either exposed or lava, then we continue because it's already there. Yeah. And otherwise, we're gonna do grid in grid set, I guess it is. I guess we can do, grid point equals exposed. And again, we can take a reference here. Okay, then we shouldn't need to do this, that these things are still usizes, so we should also change this to signed integers. Yeah, and this is I32. Okay, so we have the neighbors now. Beautiful. And the scan size, yeah, we are comparing this to usize, which is beautiful. Oh, but actually, we don't need. We don't. We can now say, we can actually now have the scan size be the actual number that we want, and say, let's inbounds be if, actually we're not using this, right? Oh yes, we're using for that. So if nx is between or out of bounds, I guess we can yeah, we can say inbounds. Okay, if nx is greater or equals to 0 and nx is less than, this time, scan size, and same thing but with ny, and same size but with nz. So here should be, probably we want some, this is ny and this should be nz. Beautiful. Okay, and this is the condition if inbounds. And scan size can be an e size, and that's it, or I32, I guess. Grid, we don't need this. What else? This thing shouldn't be this, should be that, and we don't need to do the hack of adding zeros, I think. So we no longer need the turbofish here. And if it's this is the check here. All right. Oh, and now we want to, what do we want to check here? We still want to only check for exposed, right? So this should be something like matches grid neighbor. Now this is get this neighboring point. If it matches exposed, then fine. And what is the neighbor? Of course, it's this thing. If it is some exposed, I think this makes sense. This sort of makes sense. What's your problem here? You don't like this? This point is a reference. Do you need a diff reference here? What is it that you don't like? Cannot assign. Okay, so it is insert instead of this. Okay, so insert, the key is going to be the point, point, and we're going to insert a leva at that point. And here, what's, I probably need to, no, take the reference here. No, what is the, come on, what is your problem? Consider dereferencing here. I'm just trying. Okay, so what is point? Point is a reference, and insert will take the key type. So we have to dereference that. Option. Oh. But wait, these are cube types. Why don't you? Oh, shit. It was the missing semicolon there. Okay, let's forget about that. And I guess this is the same. Yeah, using insert. So insert at this point, just put exposed, and what is the point? What is the point of life? Okay, this is exposed, blah blah blah. Beautiful, beautiful. And we are not using air, so it's either lava or it is exposed. I guess that makes sense. Anyway, we haven't run this yet. Do we still have more errors? No. Let's see if this thing actually still works. Oh, we are running release, and we are entering an infinite loop, it seems. Beautiful. Let's run it without release. Maybe we are hitting some out of bounds or something. Nope. So this doesn't run. What's the problem? There could be many problems because I changed so much stuff. So much stuff. I changed I'm sort of guessing that we are getting stuck in the fluid filling. So let's just print ln looping. Should probably learn how to use a debugger here for Rust, but yeah, we are looping infinitely. So maybe the bounce check is wrong, or maybe this condition is wrong. So when are we stopping? When we are either out of bounds. Oh, now actually we can put everything, every neighbor in the unvisited, and here just check if it is out of bounds and do an error return in that case. But it's the same, so it doesn't make sense to do anything different. So if it is in bounds if, oh, did I write it? Yeah, I wrote it completely wrong, right? nx has to be greater or equal to 0 or less than scanline. Yeah. And here too, and here too. Yeah, okay, that was a stupid error. And now now it's finished looping, but the answer is different. 1996, which still looks like a date, but the other one was 2010. So I'm off, but not by much. Did I change something in the fluid fill that makes this go pretty stupid? I wonder. This condition now looks better. If it's less than the scan size. You know what? I'm going to include the scan size just in case. I'm suspecting this being on the edge of some of these limits. Wow, 2004, so there was something on the edge, but we are still... Oh, there could be... We have to go to -1, actually. Yeah. So, let's say... it's in bounds in this case if it's more than 0, but let's say it's actually in bounds in this case. Yes, now it's 2010. Beautiful. And now it's in debug mode. It takes much longer than before, but if we run this in release, how long it will take? Will it take 6 milliseconds? So we made it considerably slower by using a HashMap. That makes me considerably unhappier. And we also have to do this kind of hack here. Yeah, not sure about this change going from a grid to a HashMap. It makes many things nicer, but it makes some things uglier. Can we... and of course this is slower because it needs to be hashing for lots of things. And hashing is slower than accessing it's inserting here in a hash a lot, and yeah, basically that flute field, but then it's also reading from the hash here. So it needs to hash a lot of things unnecessarily. I'm not too happy with that. I never want to make things slower. But I do wonder, we are early terminating here, and here we are not even putting this into the unvisited. So I don't think I can save too many hashes. Yeah, maybe if we change, let's try something. Let's try, instead of using i32s for everything, let's change all of this to i8. So just signed bytes. I think the answer should be the same. And well, the runtime difference is probably noise. Well, it seems to be faster. That you can probably get much better than this. Yeah, I sort of like the 3D grid better now, as we are seeing this. Can we do something different? Yeah, no, we're hashing. Now points are less than 1 word size, so it makes sense that the hashing is faster. But I don't know if I like this. Do I? Well, also I don't know if I like being programming at 2 in the morning. So maybe I can call this a day and continue tomorrow. Because I'm probably not thinking very clearly right now. Let's see, let's check if this makes sense. So maybe I'm tempted to maybe commit my first solution without this improvement. Or we can, let's actually take a look at the difference here, if it's actually makes things better. So this is not much better. And let's close this. This is basically the same. This is also basically the same. This, well, this is nicer now. Sure. And yeah, but it was nice to actually check that the problem, like the input, we proved that there were some pockets that like on the sides of the boulder. So that was nice to check there. Yeah, this is, I mean, I'm starting to like the grid solution better, even if it has this hack. So yeah, I'm not happy with the change to a hash. Let's actually add this change, but this I'm going to discard, to be honest. Doesn't make sense to make that a hash. Yeah. So this thing now should run fast. I mean, 4 milliseconds is nothing, but I never like to do things that take longer, even if it's a drop in a bucket. Just to, I like to practice, being nice to the computer and to having things in memory, you know, laid out in an efficient way. To basically, I'm learning Rust to learn some low-level programming, so it makes sense to care about these things. So I'm not too happy about this wrapping sum here, sub, but let's not think about that. Let's not think about the grid and forget about that idea. We are going to let this be. But one thing that I was maybe thinking about changing here is that we can, well, collect into this. And we can maybe say, well, here we have the numbers. Yeah, it's the same. I was thinking of maybe doing some pattern matching here, but I don't think it makes anything better. So let's leave it as this. I mean, well, let's write it down and see if it makes things better, actually. I was thinking of if let blah blah be nums. So we are pattern matching, else panic, there should be free coordinates, and what are you complaining about? No, is a let else array or slice, I think. Yes. Can't you? Oh, I think what I'm meaning to do is something like this. Yeah. And now we can return here x, y, z. So yeah, it's a bit of an improvement, I guess. Unknown words, of course. We can call it coordinates. All right. I think I'm okay with this solution. The neighboring, the code that gets neighbors is probably something that we can take care of. Or maybe the repetition between these two. But I guess that can be a problem for tomorrow. For now, I want to get some rest, so let's commit this and say day 18 solution. And that's it. That's it for today, at least. Let's see if I don't procrastinate this many months more and continue tomorrow with this solution and keep going with Advent of Code. So thank you very much for watching, at least if you have been watching. Thanks for doing so, and see you later. Bye-bye. Well, actually, not bye. I just pressed stop recording, but I noticed that there is a very obvious refactor that we can do here, and I'm going to go to sleep much soundly if I do it now. So these two loops, where we are basically counting the neighboring points to these droplet points, and here we are basically counting things that are not lava, and here we are doing the same and counting things that are exposed. But well, here we can actually say, since we haven't marked the exposed things yet, we can say, hey, count things that are there for now. They should run the same. I shouldn't be running this in release mode, yes. But now we can extract this function and say something like, let's say, extract into function. The function name is count droplet area. Yeah. Yeah, counts droplet area or calculates area. It's the same. Or it could be count droplet exposed faces, but let's say calculate or get droplet area. Beautiful. Droplet points. Why are you giving me this? This should be actually, we have the extraction. I think the language server is not very intelligent when doing this kind of things. It's like we have declared this to be points and oh, the grid type. Yes, the grid should be a reference to a grid. Here we can pass a reference. Whoops, take a non-mutable reference. And what else we need? We need to say which neighbor type to count. Cube type. Yeah. Get droplet counts. I think a more like direct naming for this could be count droplets neighbor points. Yeah. Oh no, we are not counting that actually. Are we? What are we doing? No, yeah, we are doing the exposed area in some way, yeah. But this is basically the neighbor type to consider for this area. So first we are considering the air, and then we are considering the exposed. Yes, sort of makes sense, I think. That's it. Now I am again doubting about everything, but let's not do it. Get droplet area. We're going to pass the droplet points and the grid and say exposed. And we get the same result. Okay, I'm a bit dubious about this name, but other than that, it's nice to have gotten rid of that obvious duplication. Area, fluid fill. And we can actually maybe declare these things sort of in the order that they are used. Something like this makes more sense, I think. Okay. I think I like this better. Let's check that it still runs. Yes, so let's git add updated and git amend to just add it to the previous commit. Okay, so yeah, now I'm happy and I think I can go sleep more soundly. Thanks for watching, and see you next time. Bye bye. Hey, hello there. So it's the next day now, and well, I wanted to give this solution for the 18 a final look, and maybe yesterday I was coding this in the night and I was a bit tired, and I think there are a couple of things that could be improved. So let's maybe improve those things and finish up this code and leave it in a state that that I would like. The first thing that comes to my mind when reading this now with fresher eyes, I guess, is this hard-coded scan size of 22, a very specific number. Although we know the reason for this, which is that these numbers in the coordinates for the 3D points, the maximum, like they go from 0 to 19, so they are 20 numbers. So you would need a grid of 20 by 20 by 20 to put that scan. But also we are leaving one to each side, so we are expanding the cube to one on each coordinate, so we can then fluid fill it and take the correct shape of the droplet. So that gives us 22, and yeah, it has a reason to be, but maybe I would be I could explain what I just said in a comment here, but I think maybe I would prefer to try to de-hard code this, or soft code, I guess, this thing, and calculate it given the droplet points, so we don't have this hard-coded thing. So let's try to do that, actually. Let's remove this, and a bunch of things will break, but let's see. Here we would need something like this scan size. And by the way, maybe I would like to call this thing, well, first of all, if we make this non-hard-coded, this cannot be static arrays. They will have to be vectors, like dynamic vectors. So this would be a vec of a vec of a vec of this thing, and this would be, let's call it grid size. And how are we going to compute the grid size? Well, I guess we can get the droplet points. And by the way, I'm probably going to keep this assumption of the grid being the same size on each direction. We could also measure the max x, max y, and max z. But we know that the maximum value of them is 20 or 19, so it's fine. It's fine if this thing is a cube, basically. Like I don't care if I'm wasting some bytes doing it a bit larger than it needs. So okay, how are we going to do this? We have the droplet points, so I guess we can iterate and get each of the coordinates here, x, y, z, and get the maximum out of each. So I guess we can do x, max y, max z. I think this is one way of doing this. And once we have, this maximum function, I think, what does it return? I think it gives us an, this max between 2 gives us what we want, but the maximum on an iterator, I think it gives us an optional. So we have to say something like not or, get or. Unwrap or. Yeah, unwrap or 0, maybe. complain about? Yeah, sure. So grid size, we can dereference this. And actually this will be the maximum coordinate, not the grid size. We would have to do +2 here. Yeah, this code is not the prettiest one. I wonder if doing a loop would be would be better. Let's continue with this, but sometimes this iterator heavy things or iterator heavy code makes things a bit less readable, I guess, than a simple for loop. But anyway, now our grid type can be a vector of vector of vector of cube type. So a 3D dynamic vector. This +2 could require a comment, I think, because yeah, we know that this maximum number is gonna be 19. Yeah, maybe what we can do is grab this and call this max coordinate, and yeah, leave. Yeah, this is a bit better, I guess. Okay, then. Now here we have the parsing. Oh, now we don't have to check this. Do this check because it's not a static limit, this scan size. So that's nice. It goes away. And I guess now we can probably do. I can move this hack down like this, or maybe even separate it. Yeah, maybe have the parsing and then do this. Yeah, we first parse things into numbers, and then we do the hack of moving everything by 1. I think this hack is still needed because we need to do the fluid filling. Do we still need the turbofish here? Yes, we do. And the rest is fine. Here we're taking a grid, which is now a 3D vector, which is fine. These algorithms should be the same, I think. Oh, and here we are checking if these things are in bound when we do the fluid filling. We could pass the grid size here, but we could also compute it, I guess. Is grid length, and here then all right, so does this work as we intend to? Yes, the answers are still the same, so I guess this is still running, and we got rid of the hard coding of that hard coded scan size. But I think that's a nice change. We can take a look at the changes. This became a bit more complicated, the initialization of the grid. But at the same time, I much rather read this than this. We don't have to do this checking while parsing. Yeah, I think I like this. I may want to try to maybe calculate this instead of using iterators. Maybe try old-fashioned for loop. So let's say let's mute max coordinates. It's gonna start at 0, and we're gonna do for x, y, z in droplets points iterator. What we can do is do max coordinates be the maximum between what it already is and this thing. So it's basically the same algorithm as this, yeah, but expressed with a mutable variable and a for loop. And do I like this better than this? I think I do. Yeah, it's a bit more imperative, but I don't know, I find it more readable. And let's put a comment here, leave the grid size instead of having grid size be the grid size be one more than the max coordinate. Add one more space to allow the fluid filling to fill holes in walls, we can say, or to fill spaces where the droplet touches the grid sides. The grid size be okay, yes. Then we have the grid size and the grid over here. That's nice. Let's keep this change. Is there something else that we could improve? I was thinking also that I'm not sure if I like this enum of cubes being possibly lava, air, and exposed. Like exposed seems to, yeah, seems out of place there. And can't we get by with two values of enum, like lava and air? And maybe if we have an enum of 2, we can use a bool. Like for the first part, of course, for part 1 we can use a grid, which like we can initialize all of this to false and have the lava be true. But on the second part, we need to do the fluid filling. But I wonder if we can probably do the fluid filling with another temporary grid here, where we mark the things that we have visited, and then just fill the original grid with, like, fill the pockets of air inside the droplet with lava, maybe. Or maybe we can return a new grid from here. Yeah, and in that, I think that could work. In that new grid, do all the calculations. Like reading this would be read-only. And we could do, yeah, let's try that actually. Let's change the grid to be, We initialize it all to false instead of those cube types, and we do true here. And what else? We say that the grid is a vector of blah blah and bool. I have my cats over here. And yeah, we can say here true equals lava. Look at that very succinct comment there. And if we say this, when we're computing the area where we take the grid, we cannot do this calculation. So here we are checking the neighbors that I think that are not lava. Yeah, something like this. I wonder if this works for the first part, or if I have already made a stupid mistake. Cargo run release 18. Well, we have warnings, but yeah, the first part still I get to equal numbers because the fluid filling is not doing anything. But yes, this doesn't care about, like this works all right with booleans. And now the fluid filling, we have the grid size, and I wonder, so this grid represents the droplet scan. What if we do something like, let's call this scan grid. No, let's keep it as grid, but I want to have another grid be the field grid, which is the same. We're gonna do a vec of grid size, but of what? Well, of a vec of grid size, of true. We can start with like the new grid, and finally we are going to return this new grid, fields grid, and here we're gonna say that this returns a grid. And this is complaining probably because the syntax for this macro expects semicolons. Yes. So yes, I think we can start, like in this grid we want to get rid of the air pockets, so we start with everything filled, and we're gonna fluid fill with false values. Yeah, I think that makes sense. And here this matches, that is asking if the previous algorithm was either exposed or lava. Well, the or lava part is the same as asking this, if this boolean. And we can say this or field grid what does it mean to be exposed? It means to be false, because we are going to be, let's not make a stupid mistake here, x, y, z. If this is false, this means we have already exposed this, and we, we have already visited this this point. So we cut the fluid filling here. Then we can say, oh, and by the way, here we are not going to take this grid as mutable. So here, this thing would be the fields grid. I'm gonna say this false. And you don't like this because probably this is not mutable. And is that it? Is that it? Of course, we have to change. Here we can say fields grid. And here we can pass the field grid. Look at that. That looks nice. I think that looks pretty nice. Does it work though? There are some warnings. And yes, it does work. Nice, I really like this. And I think we can totally get rid of this cube type now. Bye-bye. And yeah, we are not using this now, so bye. And bye. And bye. Very good. Get droplet area. Does this name make sense? We can call this. I want to call this something more like count the cube faces. Count exposed faces, because now maybe get droplet area. Exposed area, I want something like exposed in the name. Count exposed faces. Let's see. Yeah. And when we are float filling now, I think a better name for this would be something like fill droplets or fill air pockets. Yeah. I think this sort of makes sense. Yeah. Now what I'm thinking is, here we have filled this and created a new grid. This count exposed faces could actually only receive the droplet points. Like, we could generate more droplet points from this filled grid. Do I want to go that route? It does seem interesting though. But maybe that's gonna be more complicated. Yeah, this still runs, and now we have no warnings. So this is a good change, I think. Yeah, it's simplifying what these things receive. We don't need this enum. Yeah, I very much like this change. So let's add it too. We could do more atomic commits, but I don't care about that now. Okay, I'm okay with this parsing. Oh, the other thing that I wanted to maybe take a look at is this neighbors calculation, because yeah, so we have two different places where we are computing the neighbors, here and here, and we are doing it in a different way, because here these subtractions, like this XYZ, are unsigned, and these subtractions could underflow if any of the coordinates is 0, but we know they are not 0 because the dropped points, we have forced them to start at 1, to be at least 1 when we parsed, because here we added this 1. So yeah, this does technically work, but we cannot get away with that here, because here we are going until the edges of the grid. So here we do a wrapping subtraction, and this will underflow and go to a very big number, and then we just check if things are inbound in here. So I was wondering if we can extract this to a common function and reuse it in both places. And I don't know if that will make things simpler or not. Let's see, let's copy this, because this is the more generic case. And if we say function neighbors, I don't want this function to return, like do allocation, dynamic allocations, like return a vector of neighbors or something, because basically what I want is what do I want? Here from these neighbors, we are checking if they are in bounds. So I would like to have a function that you pass a point and it gives you exactly the amount of neighbors that point has. Most points will have 6 neighbors, but the ones that are on the sides are going to have 5, and the ones that are on the corner will have like 3, if I'm not mistaken. But the problem is, I don't know if I can do that without dynamic allocations. Let's try. Like, what if I return an iterator from this and say, well, this will receive an x, y, z coordinates, which will be a point, and return like an iterator, which I don't know what specific type of iterator it will be, but which item will be point, right? Does this work? I don't remember exactly. The trait iterator is not implemented for. Okay, maybe it's complaining about it to do. That doesn't make a lot of sense, but okay, let's try it out. We're gonna have the neighbors, and what are we going to do? What if we do neighbors just into iterator? Does this work? This works? Why? I was expecting this to actually fail because of this, like this iterator needs to know about this array. So if we are returning this, how is this not referencing something that is dead, like that doesn't live enough? I think we can do a trick here. If you put any other type that doesn't match, Rust tells you the actual type of this. Expected bool, and found an array into iterator of this, and size 6. So there's an into iterator type for static arrays. So this into iterator is probably keeping a copy of that array, which I guess is fine. And we can filter this, right? Wait, let's go back to this, and we can filter. And we are gonna filter. These are the neighbors. Yeah, we're basically going to filter by this. And ask this same thing. This means that it is in bounds, right? Oh, and it needs the grid size, so I guess we can pass it. Why do you complain? Because you need, yeah. Oops, what's the problem? Oh, closure function problems, nice. Oh, but it's complaining about the grid size. Let's check the error here. Okay, it's just putting move here on this closure, so it's will. This is something that I still don't get about Rust. Why things that are trivially copyable, you need to say, hey, move these things into this closure, like a usize, like an integer, basically. But now it doesn't complain, so, and I guess now it's going to be returning like that iterator wrapped into a filter iterator or something. Yeah, filter of this, blah, blah. Okay, very cool. So does this work, actually? Here, instead of saying neighbors, can we say neighbors iterator of what? Of the points XYZ and the grid size, and not use these neighbors, and also not do this. Does this work? Yes, it does. Nice. I guess if that works, it should work for here too. So we can say neighbors iterator. Here actually we can get the point and the grid size, which I guess the grid size doesn't exist. We can copy the definition here. That's all right. And the points, yeah, we can pass it like this. No need to say into iterator. Yeah. Does this work? Okay, cool. I thought this was going to be much more difficult. I guess we can say just neighbors. No need to say this an iterator. It's already set in the return value. And we can even probably inline this variable. And yeah. It looks a bit wonky here, the formatting, but I guess it makes sense. My cat really wants to be on my lap today. Yeah, pretty cool. And here we just, yeah, I like the simplification on this fluid filling algorithm. It's just, yeah, get the neighbors of this and put it in the unvisited array or vector. That's really nice. Okay, so I'm pretty happy with these refactors. The last thing I may be wondering is this idea of maybe having count exposed faces only receive the droplet points and not care about the grid, but that would need I would need to go back to droplet points being a hash set, and in here we could have the original grid. I mean, it's not bad. we would put all the grid logic inside of this fruit filling thing, and the rest of the code could just work with a hash set of points. I wonder if it would make this function more complicated, but at the same time it would make the rest of the code a bit simpler. Does that make sense? Well, I'm happy with these changes, so let's commit these ones for now. What are we doing? Day 18 MISC improvements. What did we do actually? We remove scan hard-coded scan size and use a dynamic grid instead. We also removed the cube type enum and just used a grid of bools. Yeah. And the last thing, we extracted the neighbors function. Neighbors function. Neighbors logic into a function. All right. Those are some nice changes.